We have split section 4.6 into two halves, and 4.6b is actually not in the algebra book, but it is a skill that we would like all the algebra students to know. So composite functions, you can find more about them online, you just won't be able to find them in your book. So a composite function, or a composition of functions, is just when you, if you think of a composite rock, it's got several different rocks mixed within it. So a composition of functions is simply just more than one function. Okay, so multiple functions. And there are different operations of functions, and we can do an example of each of these, no problem. But if we wanted to find h of x, we could add two functions together. We can subtract functions, we can multiply functions, we can divide functions, and I can give you an example of these, but they're actually pretty easy. So we're actually just going to go straight into these, and we can discuss some more examples tomorrow. So example 1 says f of x is 3x squared plus 1, and g of x is x minus 5. So it says that we want to figure out a composite function, h of x, and it's made up of, or is equal to, f of negative 3 plus g of 2. So we find each of these individually, and then we do what the operation says, which is add them together. So f of negative 3 would be 3 times negative 3 squared plus 1, and that's the f function, plus the g of 2, so that would be 2 minus 5. Now you really don't need the parentheses here. Okay. So here's the f function, here's the g function. We find them individually, and then we add them together because that's what the operation says. Now you need to be careful here. Order of operations says you do all exponents first. So negative 3 squared would be 9. 9 times 3 is 27. And 27 plus 1 would be 28. 2 minus 5 is, of course, negative 3. So we have 28 plus negative 3. So we get h of x equals 25. And that's all you're doing here. Find them individually and then do whatever the operation says to do. Subtract them. In this case, we're multiplying them. In this case, we're dividing them. So we'll do one more together. We'll do this division one, and then I'll have you do these two on your own. So example 2, we're using this f function and this g function. So h of x is g of 2. Make sure you're using the g function, which is 2 times 2 plus 14, divided by f of negative 9. So 2 times negative 9. Okay. Now 2 times 2 is 4. 4 plus 14 is 18. 2 times negative 9 is, of course, negative 18, and this all simplifies to be negative 1. Very simple. Just telling you what values to plug in, and then follow whatever the operation is. So I'd like you to do example 1b on your own, example 2a on your own, and bring those to class with you tomorrow. Composition of a function with a function. It's down here at the bottom, but it actually goes on to the back side. And this one is the more challenging of the two. All right, so by definition, the domain of H is the set of all the x values where x is in the domain of G. And G of x is the domain of F. Now that sounds like a lot of words, okay? So let's look at a problem. This can be very confusing. Let's look at a problem and see what all of this means. So in example 3, it says f of x is x plus 2, g of x is 2x squared. Looks like the other examples. However, here's the difference. We are finding f of g of negative 2. And as with other parentheses, we always work from the inside out. So let that be a reminder to you that we're going to work from the inside out. Now I'll show you two different ways to do this, and then you can decide how you would like to do it. So one way you can do it working from the inside out is to make a little table if you want. So we're going to do the first function first, which is g of negative 2 from the inside out. So this is the inside, this is the outside, okay, inside out. So g of negative 2, no problem, is 2 times negative 2 squared. So we're just putting negative 2 into this function. Follow the order of operations, which means you're going to square this first to get 4, and 4 times 2 is 8. All right. Now, since g of negative 2 is 8, you could get rid of this, and now we have f of 8. Because g of negative 2 is equal to 8, now we're doing f of g of negative 2, which is 8. So f of 8, this is the outside now. The f function is on the outside. So f of 8 would simply be 8 plus 2, and so your final answer would be 10. And you can write that out, f of g of negative 2 equals 10. So if you go back up to the original, it would look like this. F of g of negative 2 equals 10. F of g of negative 2. Or if you're going to use this setup, you can make sure you circle your final answer so we know which one it is. Okay? So that's one way that you can do that. A lot of people like that way because there's a lot of organization, and you know you're always doing inside and outside. Another way you can do it is just by working within the problem. So you could leave the g there, and then f of 3 would just be 3 plus 2. And you can simplify the inside, so we get g of 3 plus 2 is 5. And then you do the g function, which in this case ends up being the outside function. So you still do the inside function first, but you just do the work here. And then you continue down with the outside function, g of 5. So that would be 2 times 5 squared. And again, order of operations says you square this first to get 25, and then multiply by 2. So that would be 50. So g of f of 3 equals 50. Okay. So I want you to see how well you can do on example 4. Try A and check it, and then try B and check it if you'd like. So pause here and do just A. And pick a method that you think made the most sense to you. Okay? Pausing here, do A on your own. So if I do the table way, again, this is the inside, this is the outside. F of 4 would be 3 times 4 minus 1. That's 12 minus 1, which is 11. Now we're doing g of 11. So that would be 2 times 11 plus 4. That's 22 plus 4, which would be 26. So our function, or our composite function, would have a value of 26. Now whether you did this method or this method, the final answer should be 26, the value of it. Now, I want you to push pause and try B without looking first, okay? Give B a try and then check your answer. So I'll do it this way this time. So f of g of negative 1. Now g of negative 1 would be 2 times negative 1 plus 4. So we leave the f out here. 2 times negative 1 is negative 2. Negative 2 plus 4 is 2. Then f of 2, go to the f function, would be 3 times 2 minus 1. Oops, don't need any parentheses. So we get 6 minus 1, which is 5. And you can circle that answer at the bottom if you like, or you can write f of g of negative 1 equals 5. As long as I can see what the value of the function is, the composite function, then we're okay. So what it's saying is that when you plug in negative 2, which is the domain in this function, because that's what you're plugging in for x, it gives you the y value, and that then becomes the domain of the f function. So that's kind of what this is saying here. The domain of the h is a set of all x values where x is the domain of g and g of x is the domain of of f. So f of, you can't see that. So x is the domain. You're plugging in all the x values. X ends up being the domain of the g function, and then g of x becomes the domain of the f function. So x is what we plug into the g function, and then g of x, the value of it, is what we plug into the f function. So that's what this is saying here. We can also use this to apply to a word problem. So this example says J. Crew is having a sale where each customer gets $25 off his purchase or her purchase. Over the weekend, Bruce Springsteen goes to J. Crew to take advantage of the sale. When he gets to the register, he realizes that he also gets a 15% discount for being a singer-songwriter. Write a function to represent each discount. So the sale price and the discount price. So J. Crew is having a sale where each customer gets $25 off his purchase. So that's the sale price. So we get f of x is x minus $25. That's the sale price. Because he's Bruce Springsteen, he also gets a 15% discount. So we have a second function that says that g of x is going to be a discount of 15%. So we have to imagine g of x isn't going to be the 15% because that's not what he's going to pay, but it's going to be 85%. He will only pay 85% of it. Okay, so this is what he'll actually pay, 85%. This is what you'd actually pay with the discount, something minus 25. That's what you would pay. So you have to be careful. If you get a 15% discount, you can't use the 15%. You have to think about what you'll actually be paying. So how much does Bruce Springsteen have to pay if the store takes the 15% discount and then $25 off her purchase? So we're talking about this, h of x. If he gets the 15% discount first, that's going to be on the inside. That's the first function, so it would be on the inside. So that is the g function. So the g function would be on the inside because that happens first. And then the f function would be on the outside. So f of g of x. So if we were to write an expression for this, because we don't actually know how much the purchase was, what we can do is plug in what we do know. G of x is 0.85x. All right? And then f of that would be 0.85x minus 25. Okay, so that means if we know that Bruce is paying, or the item costs $35, what we can do then is plug 35 in here. So 0.85 times 35 minus 25. And this would be how you would calculate the total cost after all the discounts. Okay, but it's actually different depending on what stores you go to. Sometimes they take off your coupon first and then your discount second, and sometimes it's vice versa. So how much does he pay if the store takes the $25 off first and then a 15% discount? So in this case, the h function, or the composite function, means the $25 is going off first. So the f function is going to be on the inside because that's what's happening first. And then the g function In this case, the 15% off comes second, so that is on the outside. So one on the inside always comes first. Inside out, inside out, inside out. We never say outside in, outside in. So in this case, the f function is x minus 25. So we're doing g of x minus 25. And now in the g function, we put x minus 25 in place of x. So we get 0.85 times x minus 25. So again, if the item costs $35, we would do 0.85 times 35 minus 25. So this, of course, becomes 10. Oh, I'm sorry. There we go. So the $25 comes off first. That's on the inside. And then we do 85% of that. So 35 minus 25 would be $10 times the 85% that we're actually paying for it, which means it would be $8.50. That's a pretty good deal. Now let's figure out what this would be here. Why don't you figure out what that would be, and let's talk tomorrow about the difference between how much it would cost here and how much it costs here. So go ahead and finish that one on your own. We'll talk about that tomorrow.